climate change is a system failure problem. I would love this video to convince you of that. I'd like the video to be examples of system failure, showing how this applies to climate change, and convincing you that climate change is a system failure problem. You write in the comments, "Thank you, Jen, you explained it so clearly." Instead, I think after discussing some examples of system failure, maybe you might see why convincing someone that climate change is a system failure problem is difficult because of the nature of a system failure problem. Let's get into the examples. First example of system failure, immune system failure. So normally, if you have a scratch or a cold, ideally you have an immune system that can handle that, and it's not a problem. But let's say your immune system has failed. You do not have white blood cells. Then a little scratch or a cold could be a big problem. But what is the problem? Is the problem that diseases exist? Is the problem that you could get injured? Or is the problem that you need to fix your immune system? You could solve these kinds of problems in two ways. You could either attack the specific issue. You could try to prevent disease by avoiding other people. You could try to prevent getting injured by taking extreme precautions. And you could monitor the body so that if there is signs of a problem, you address it right away. Another thing you could do is fix your immune system. Now, that might be easier said than done. Maybe in the future, one day, we'll just be able to reboot the immune system. Maybe today you could get a bone marrow transplant or something of that nature. If you could fix your immune system, if that was possible, that would be ideal, because then you don't have to worry about all kinds of problems. When you have a system failure, it might be difficult to recognize the problem because you're used to your habits. You're used to not worrying if you have a little scrape. It might be difficult to really understand that your immune system isn't working anymore. To realize you need to do something about this. You need to change. You either need to change to fix the immune system or change to avoid problems caused by not having a good immune system. So immune system failure is an example of the system failing. Another kind of system failure problem is when the system's great. The system is doing really well, it's doing what it's supposed to do, but we're encountering a situation that that system can't handle. So imagine you have a military that has the best cavalry ever. It's anything to do with horses, the military can handle. The horses can trot and prance and gallop. The discipline is just amazing. Everything to do with horses, this system has. This system is not necessarily designed to handle a cyber attack. So it's a great system, but just not for the problem at hand. So let's say you have some computer expertise, and you see the vulnerability, and you try to communicate with the military. Now, just like the military, you are interested in security and protection and defense, but you speak a different language from the horse people. They might not understand all your techno-babble.
A Trojan horse attack, you've explained this, but I don't see how a Trojan horse attack would affect the health of any actual horses, so I don't see how this is a problem.
They might not see you as an authority. If you are used to a military expert knowing how to ride a horse, you might not take the advice from somebody who doesn't know how to ride a horse. So you got to choose. Do you try and work within the system, or do you create a separate system? If you work within the existing military, it's going to be hard to change them over, because so much of the way the system is horse-focused means that it's not understanding computers. You arrive with your laptop ready to take on cyber attacks, and yeah, they have a barn for you, and they have horses and stable boys and horseshoes. They don't have electricity. They do not have the capacity, the resources, the imagination to support computers. But if you build your own system from scratch, it's just you on your own without the resources, that's also difficult. And when you build your system, if you're taking resources from the horse people, you are destroying their system. It's not going to be perfect if you're taking resources and putting it on computers. And so you can see why they would resist that. Their whole careers have been based on being great horse people, and now you're trying to do computer stuff. The third example is actual computers. Let's say you're in space and you're in a generation ship and the AI computer is running everything, and then it gets a bit wonky. Now the computer says it's fine. Do you trust that? You have a habit, you have a system. You do not mess with the computer. You don't go inside. You don't play with the software of the computer. If you want to make changes, you vibe code. You ask the computer to make the changes. How would you even find if there is a problem and fix the problem? You can't take the computer offline because you need it to run the ship, but also you need to diagnose, you need to fix it. The computer system might be able to handle some problems, but by the time it gets really big that the computer system is threatened, it's going to be really hard to fix that system. Especially if you've been telling all your computer scientists and engineers, stay out of the computer, don't mess with this. That works for a time. If you have engineers who are constantly making adjustments to the computer, they'll have experience, they'll know how to manage the system. But if it's your first time dealing with a super big problem, that's tough. It might help in this situation to have two operating systems. You have a computer and a backup computer. Ideally, a computer that runs with a different operating system. So whatever vulnerabilities you have to your primary computer hopefully won't affect your backup computer. The difficulty is your heuristics. You're used to thinking, oh, don't worry about a scratch. You're used to thinking, I trust people who know how to ride a horse. You're used to, don't mess with the operating system. And that works. And when you're in system failure, you got to do things differently. And you can't rely on these mental shortcuts that have served you so well. It's not just that we have emissions, it's that our problem solving to deal with a problem like emissions, that system isn't good enough to deal with a problem like climate change. Because if we knew what to do and we had a system that could handle it, we would have handled it by now.